All right, 37 here. Perform the indicated operations and simplify. Assume that all variables represent positive real numbers. So we've been given the square root of 5x plus 2 times the square root of 125x plus 4 times the square root of 80x. And just like before, I'm going to take each of these terms, and in this case, each term has a radical, and I'm going to break it, meaning the radical, down into good stuff, bad stuff. So here we'll have good stuff, bad stuff, plus 2 good stuff, bad stuff, plus 4 good stuff, bad stuff. All right, so we haven't really changed anything, except since we know that we have to simplify these radicals, we are going to be breaking what's underneath the radical in each term into good stuff, bad stuff. So let's go ahead and take a look here at this first term, this square root of 5x. Well, is 5 a perfect square? No, 5 is not a perfect square, and there's no other perfect square that we can multiply by some other number to get to 5, so all of the 5 is bad stuff. All right, let's take a look now at our variable. Well, what is the variable? What's the exponent on this x? It's a 1, isn't it? And you may recall from several videos prior to this one where we talked about how to deal with variables and their exponents. What we want to do is go to our index, or our root, and whatever this number is, start thinking in terms of that number. So in this case, we have a 2 is our index, so we want to think in 2, 4, 6, 8, multiples of that index. And we want to ask ourselves, is 1 a multiple of our index? Well, no, it's not, right? I don't see the number 1 listed here. So our next question is, what's the next number down from 1 that is a multiple of 2, our index? Well, again, looking down this list, I don't see any. So that means that this whole x to the first, or again, just x, because we don't really have to write that 1 there. This x, all of it is bad stuff. We can't extrapolate any good stuff from it. So for our first term here, radical 5x, all of it is bad. All right, let's take a look here at our next term, 2 times the square root of 125x. Well, our 2 is on the outside. That didn't change anything. But what we are changing is we're breaking down this radical 125x. So first things first, is 125 a perfect square? Well, no, it's not. But is there a perfect square that we can multiply by some other number to get 125? Well, the answer is yes. We could take the perfect square 25, multiply it by 5, and we arrive at our original 125. All right, and now same process with this x. Well, we don't have to go through the whole process again. We know that this x is to the first power, and so all of it is bad. So let's go ahead and put that x in the bad stuff. So when we break down radical 125x, 25 is good stuff, 5x is bad stuff, and if we were to multiply these two things together, we get back to our original 5, or rather 25 times 5 is 125, and this x is this x. All right, last but not least, let's go ahead and take a look here at the last term. 4 times radical 80x. Is 80 a perfect square? Well, no, it's not a perfect square, but is there a perfect square that we can multiply by some other number to get to 80? Well, yeah, we can take the perfect square 16, multiply it by 5, and we arrive at 80. 16 times 5 gives us 80. And again, here's this same old x again, so we know right away that that x is going to go into our bad stuff. And you might notice a pattern here. What's happening with all of our bad stuff? They all start to look exactly the same, right? So that's kind of a little clue to you when you're doing your homework or taking a look at this practice test or the actual test. When you see that they've asked you to add a string of radicals like this, usually the smallest radical, and in this case radical 5x, ends up being the garbage for the other larger radicals. Because the larger the number is, 125, 80, chances are you can break those numbers down into good stuff, bad stuff. But 5x is fairly small. We can't really do much with that. And so 9 times out of 10, that ends up being your garbage. And in this case, it panned out, right? 5x ends up being the garbage for all of our radicals. All right, so let's go ahead now. They want us to add these things. So here, our good stuff goes away, and we're just left with radical 5x. Here, we're going to have our plus 2. And we know that the good stuff is going to come out free and clear. So what is the square root of 25? Well, hopefully you said 5. And we know that whatever comes out of the good stuff radical, we're going to multiply by what was originally there. And so since there was a 2 on the outside originally, we're going to take the 5, multiply it by that 2. And then we're going to rewrite our garbage. So 5x. And then plus 4. This is our good stuff radical. We know this is going to come out clean and free. What is the square root of 16? Well, it's 4. And then we rewrite our bad stuff. All right, let's go ahead and clean this up a little bit. We have radical 5x plus, well, 2 times 5 is now 10 with our garbage, radical 5x, plus 4 times 4 is 16 with our garbage. And now that everything has been simplified, our radicals are all the same. We can now consider these to be like terms, and now we can go ahead and combine to find our final answer. So what we're going to do is simply add the coefficients, the number outside those radicals, and then rewrite our garbage. So we have 16 plus 10 is 26, plus 1, don't forget this 1 here, gives us 27. So 27, and then rewrite that garbage radical, 5x. And so our final answer is 27 times radical 5x.